Hey Sadie, I guess you're still on the road.
Hey, sir, can you hear me?
Yes. Yep.
Okay.
So you're still traveling, right?
Yes.
Okay. I was just setting up some stuff with pneumatics. Um, and I was just writing some code to see, just to test out. But Lawrence isn't here yet, so we'll wait a little bit. Oh, dang it. There we go. All right. Looks like Lawrence just joined us, maybe.
Hey,
Hey, Lawrence.
hey. What's the word for today?
Today's word is let me see. Encoder is today's word. Today's word is encoder. Okay. Um. Hey, Sadie, how much further before you'll be able to actually look at a screen or anything would you say you are?
Well, actually, traveling. So the wedding in Saturday, my dress got ready today. So I'm actually traveling to pick it up. Um, so it may actually be a while, but there will be a point where I can like stop, look at something quick. I'm stopped in the car.
Okay. Um, I was just gonna kind of explain the setup for pneumatic and kind of just show the different parts of it, but I can wait on that. If you want to get in a position where you can see things, or I could just kind of go over it and then it would be recorded on a video for you to go back later. I don't know. Whatever.
Okay, can you wait maybe like 10, 15 minutes, and then I should be able to like park in a parking lot somewhere.
Oh yeah, that would be fine.
Okay.
Yeah. So in the meantime, what else besides pneumatics did we have on our agenda today? So originally we are going to maybe try to put together a resource document for odometry. I don't know if we're still going to continue to try that or not. Well, how about this, Lawrence? Is there anything that you would like to go over today before we go over this pneumatic stuff?
I'm thinking, there's probably a lot. But I really don't know right now. I mean, I got a quick question on pneumatics. What? I mean, because I think we had like what we did was we used we went from the tank. I think after the tank we did the valve, and then we did the no, maybe before the valve we did the regulator, and then the
Yeah,
valve.
I don't actually have a flow regulator hooked up on this right here.
But you don't need. I think on yours though, you don't use those, huh?
Not really. I mean, that's if you just want to control how strong you want that stroke to be, I guess. But or how quickly you want the stroke to happen, right? Because you can put that
But you,
flow regulator on, but that
yeah,
flow
but you,
regulator is usually mounted directly to the cylinder, right?
no, I don't know. I mean, we learned it by watching a video. You know what I mean? Like we ordered the kit and then watched videos on YouTube. You know, but I mean, like I think when I looked at when I saw your robot, it just looked like y'all were using way less parts than us.
Yeah. We don't often use the. I mean, it didn't really seem necessary. For what we were trying to accomplish. So we just didn't use that flow regulator. If that's this. Well, there's. Let me see. Actually, there's two different. Yeah.
Let me see him. Let me see the
Okay.
pieces. Yeah.
Yeah. Let me. I can on my screen. Hold on. I've got my document camera set up too. So let me just swap to the document camera. So like one of these things, you mean?
Yeah, we use both of those.
Okay.
I have them on the video. Yeah, the one on the top, that's what makes it go fast and slow. Like,
This one or
no,
this
yeah,
one?
that one. The
Yeah,
little
this one
white
makes it go fast or slow, and then this one, doesn't this one control like the force?
That's like, I don't know. That's the one you put in the beginning. The other ones we had on.
Yeah, and this
on
you just attach like instead of having it hooked like directly, you could attach one of these, right?
Yeah, let me see your piston again.
So here's so
So
we
you have
just
the
have
same fitting on both of them, huh? They got the
yeah.
same fitting. But that's where you ordered more, right? Because they don't come enough of them to do that
Yeah,
in a
but
kit.
the fittings themselves were really cheap if you order them directly from the supplier. So um yeah, so those fittings are pretty cheap if you just wanted to get more fittings. Yeah, so yeah, and like you said, this would control the speed of it of the stroke. And I think this part right here, that would be your flow control to control the force, I believe. We just always went full speed anyway, so we never really bothered with this part.
Yeah, but those like the piece on the left, that's giving us lots of problems.
This piece or this one right here? No,
No,
this
the
one.
other one. Yeah.
Yeah, the black one. Yeah. Honestly, I don't think we've ever put this piece on a robot. Because I mean, unless you're working with controlling the flow, I guess there's not really any reason to.
Yeah.
From what I would assume though. There might be reasons, but I mean, I am no means an expert on pneumatics.
Yeah, I mean, like you said, I think it's more of a protection thing. And how much pressure you put on yours, your tank?
I mean, we always fill up to probably just a little over 100, so that way when we pop off the connection, you lose a little pressure. But
Right.
yeah, I mean, the tank itself is rated for like 200 psi, but the problem is the solenoids. And so if you put, because one of my
Let me see the
students,
solenoid. Let me see the solenoid.
uh,
Yeah, we have problems with that too.
yeah, so like if you pump it up too high, you can blow the solenoid out. And in fact, I had one student that did that at least once or twice. Because the solenoids can't handle more than 100 psi.
Okay.
So you don't really want to overpressurize it just for that fact alone.
Right. Okay. Yeah, we've got some that are blown. I've got one that like, cause the threads, it's broken from opening the box. It was already broken.
The solenoid was?
Yeah, because the threads are so fine and like the base part wasn't even threaded. You know, that white part, it wasn't even threaded.
Yeah.
You know where you screw the fittings in there?
Mm-hmm.
There was no female threads in there. It just was, I mean, it was some, but they were stripped out already from the time that we got it. I don't know. And then we've had some of those that go to leaking, you know?
Yeah. We've had some issues with the kind of leaks too. And also we had a couple where the top part of here was the where the electronics plug in was knocked off. But we were able to actually kind of super glue that back on. And the connection still worked. So but yeah, you do want to make sure they're like, I remember the first season we ever used pneumatics, which we only recently started using them. But they put the solenoid in a place that other robots were bumping it or hitting it.
Right, right.
And that wasn't good. So you definitely want to make sure it's in a place that's protected and not likely to get damaged.
Yeah, these robots take damage. Okay. What about your tank? Let me see your tank.
So
Okay.
there's our tank. Also, like talking about extra fittings and stuff. Leave this. Like for a secondary tank, you know, if we're using two, we actually have we set some tanks up with double fittings.
Yeah.
So that we can run them in series.
Now, that's what you bought from your store with those tanks?
Yeah. We
How much was that? How much
from
was
SMC. Yeah, we ordered the tanks.
how much was the tank? You just ordered from SMC?
Yeah. There was a let me see. Let's see if we can find let me see if I can find that place where
Because I mean we ordered one once and it was like $60, which was still, I thought it was kind of high. Like the kit to me I thought was cheaper. I don't know. But we never ordered cylinders. We've only ordered a tank. And maybe we were looking for a valve. Maybe we were looking for solenoid. I don't remember which parts, but there's a lot of parts.
This is a very old article. Yeah. Let me. So here's let's see. I was looking on the Vex forums and
Or could you present your screen?
yeah. So I was just pulling up this article from the Vex forums. So and it looks like it has links to, well, that is not a good link.
I think Sadie's back.
Is she? Okay, are you in a spot? See, that is
Sorry. Yes, I am.
man, back when I ordered the stuff from FMC, there was like I found a link to like a spreadsheet that someone had, and it had like links to the parts and but we ordered directly from SMC. At least I seem to remember us ordering directly from. Maybe we did go through a distributor, but it, yeah. So that's probably something we should do today. We should look up how to where we could order these parts from. So we'll take time today to research that, and so where you can find. But let's see, how old is it? This is from 2016, so I'm sure the prices have changed. But how much was the reservoir? Yeah, so like this reservoir was only $25. This is back in 2016 though. Yeah, the most expensive part was the solenoids themselves, which were like $40. But yeah, I remember the reservoir as not being all that expensive. So
we bought one for 60. I think it was a couple
really,
years ago. Yeah.
I don't remember paying much for
like the shipping and all that was, it
yeah.
was way high.
I don't remember having to pay that much for the tanks themselves because we ended up at the time we had 5 teams, so we ordered 5 kits, but then everyone wanted additional reservoirs, so we ordered like 5 more reservoirs. And I don't remember. Yeah, I remember them being in like the $25 seemed about the price I seem to remember, around that price. So that sounds about right. What is going on? Oh, that I was jiggling the cord that I had. Okay. So anyways, Sadie, so now that you can kind of see things, let me show you what's involved in a pneumatic system. So the very first thing you need is your reservoir. That's this right here. And you can see this reservoir, we put 2 fittings on it. So this fitting right here is for all your pneumatic hose. And so you can just buy the hose and you just clip it to size, however long you need it. When you are clipping the hose, you want to make sure that that you cut it perpendicular to the hose. You don't want any like angles to the hose because that'll cause like air leaks. But when it comes to let me empty this reservoir because I have some air in this real quick. So maybe if I just run give me 1 second. Let me just run this program real quick. And okay, so it's empty now. Okay, so now I can let me just kind of pop this off here. So as you can see, the hoses are all you have to do to put the hoses on and take them out. To take them out, you just kind of push this in, and then they'll kind of pull out. And then to just put them in, you just kind of push them in, and they just kind of, and then they hold in place. So they're actually pretty easy to work with, believe it or not. And so, okay, so we have our pneumatic thing. So on one side, we have just a regular valve and, or a coupling. And on the other side, we have the Schrader valve, which is kind of like a bicycle pump valve. And so that's what we use to air it up. And so, so if you can use up to 2 tanks in pneumatic, and so there's a lot of ways you can hook up 2 tanks, but what we do is we just take a second tank and we just put 2 of these coupler fittings, and then we just run one into another so that we have them both in series. And then this would run into the no, and that basically is just acting like these 2 tanks is just doubling the volume now of the air. But if you don't need to use 2 tanks, so like if you only, like last year, for instance, I think our mechanism only fired once, so there was no point having multiple tanks on it. But the next thing you want to run into is one of these safety valves. And so there's a little arrow on it that points in the direction of your airflow. So you want to make sure that it's coming out of the tank and pointing towards the direction you want your air to flow. So we just kind of hook that in. And so if the knob is parallel to the I keep on wanting to call these wires, but they're tubes, I guess. So if the knob is parallel to the tubes, that means it's open. Otherwise, it's closed. So like when you're pumping it up, just to be safe, you want to just keep it closed. And then so this hose would run into your solenoid, and that's this device right here is your solenoid, and this is actually kind of your switch that is going to be sending the air. The one right here is a double acting solenoid. So you see the air goes in on this side, and then it actually has 2 outtakes for the air. And so, and then we also have this wire that runs into a 3-wire port, and it just hooks up to your 3-wire ports on your brain. And so to trigger this solenoid, you just send either like a low or a high signal out of that port. So you just use digital out, and you say either like low or high or true or false or whatever, and that will trigger it. So in this case, it's going to this is a double acting piston right here. And so if one is triggered, it's going to push it out, and if the other is triggered, it's going to suck it back in. And so so on your brain, and let me just air this up real quick.
You use 3 nuts on that, on the cylinder part?
3 nuts?
I see you got like 3.
Oh, yeah, well, that was just because normally not. It's just I think it was because when we were sorting stuff, we found these kind of laying around, and we wanted to put them somewhere we didn't lose them. So that was just us putting them on. Yeah, but this is the end where it's going to go in and out. Usually we just have whatever it is between 2 nuts.
Well, what was on there? What was on there?
It was just a 3rd nut. It was just like when we were cleaning up in the room.
Oh, okay.
I didn't want to lose the nut, so we just kind of stuck it on there. That's all.
You use that other piece to connect it. The metal piece that goes in there.
Sometimes you mean this piece right here?
Yeah.
Yeah. Sometimes it just depends on what we're using it for. But I mean, it's not required to use that. But it just depends on what we're trying to hook up, right? So so let me air this up real quick. Oh, and let me turn off my screen share because you guys were probably looking on that very, especially Sadie. You should have said something earlier.
I don't know if y'all could see me, but I was like doing like this a few times.
Yeah. Sorry about that. I didn't. Yeah. And I'll show off those parts again. So let me just air this up real quick. Okay. And so let me just pop it off. Well, I just lost all the pressure just then. So let me air it up again. Yeah, there's a trick to popping these off without. Yeah, there we go. Without losing the pressure on them. So okay, so if you couldn't see before, okay, so here's our air tank, right? And then so that was our bicycle pump valve, and then this is just a I don't even remember what that's called, but you know, for to hook your hoses into. And then we had that running to this safety valve, which right now is closed. But we can open it up. And then from the safety valve, this is going to our solenoid. And our solenoid, so we have one intake into it and two outlets. And then also the wire just goes into just your 3-wire port on your brain. So you use one of those. So right now it's plugged into H, and if I go, and so here's our, and then you just run those into your actual solenoid right here. So right now it is under pressure, so that's why I can't push it in right now. So if we look at our brain right here, and if we go into devices and then go to our 2-wire ports, so you see on H here, if we cycle, and let me see if I can get the yeah, so get the solenoid in there too, or maybe I can let me turn off the lamp. Is that a little easier to see a little bit? So I'm going to kind of cycle through this to do a digital out to high. So that's high, and it's in this case is pulling it in, and then if I do digital out low, then it pushes it out. If you wanted to swap that, you could do that just by swapping these two hoses here. So you can make your low pull in and your high push out just by swapping the two hoses there. At least that's how a double acting cylinder will work. If it's a single acting cylinder, then you only have one hose goes in and it pushes out, and then there's a spring in the single acting that pulls it back in when you're not putting it under pressure. So that's also how you can kind of test your system and solenoid if it's working or not. Just going into once again, that was just devices, and then just like cycling through. So there we go, pulling it in, and there's it pushing out. And so I wrote also a program real quick. So this new program I just called Pneumatic. I didn't really put anything on the screen, but basically I have this button here, and if I trigger the button, it should toggle back and forth between the two. So every time I press the button, it's toggling out and in. So if I hold down the button until it's out of air, now it's out of air and it won't. Yeah. So I can show you that code I wrote too to kind of show how to use it. So let me actually share my screen one more time. And I just threw this code together pretty quickly. But as far as setting it up, so I set up that bumper in port B, and then the pneumatic, what you do is you just go to 3-wire, you pick digital out, and that's what you use to set up. So I have this pneumatic as a digital out on port H. And so this code right here, I basically made a variable called toggle to just kind of toggle between true and false. And since I wanted to, like, you know, constantly run it, I just put it on a while loop that runs over and over and over again. And basically it's checking to see if the button's being pressed. And if it is being pressed and toggle is true, then it's going to, the command to actually fire off the pneumatic is whatever or dot set. So like you can find it under, I believe it's under, yeah, sensing this digital outs dot set. And so you can set that to either true or false. So in this case, I'm just setting it to toggle. So if it was true, then it's going to fire true. And then I'm going to set my toggle to false. Otherwise, that means it was false, and I'll still set it to toggle, so it'll be false, but then I'm going to toggle it back to true. And then I put in a little bit of weight, because otherwise, when you press that button, you don't let go fast enough, and it's just going to like do it a whole bunch of times. And you probably saw that as I held down the button, it was just like firing back and forth. But really, it's really just a matter of that digital out set to whatever value you want when you want to use it. So it doesn't really get more simpler than that. I mean, it's just, you just set it to true or false if you wanted to fire one way or the other. And it does default to I don't remember what, but that's just a matter of if it's in a default setting, like when you run your program and it fires off and you didn't want it to, that means you just have the hoses backwards. So you just swap the hoses around. And that's at least that's about as far as we have got with it. There are, like Lawrence was mentioning, you do have these regulators that you can also add in, like this. Let me stop this share. So like this black regulator right here, I believe it controls the air pressure. So if you don't put a regulator on, it's just going to go full pressure. So if you don't want to apply as much force, because you can just kind of twist this valve here to control the pressure. And then if you want to control the flow rate or the speed of it, then you also have this, which you kind of like reach in there with a screwdriver and twist this, and that will control your flow rate. So that'll control like the speed at which the piston goes in and out. So if you want it to just be slowly acting, then you could throttle that back a bit. But if you just have it hooked up bare like this, then it's just going to go, you know, as quickly as it can. And once again, this metal here is pretty thin, and so depending on how you have something connected to it, if it's pulling it one way or another, you can really bend this out. Be kind of careful about. So there's still a little bit of air pressure in this one, so that's why it's popping back. But we pretty much drained it. Let's see if it will fire anymore. Yeah, it's not even triggering now. But that's kind of the basics of pneumatics. Some things to consider when you're designing with the pneumatics is the stroke leak that you have to work with. Whatever you have this attached to, like if you're doing any sort of linkages, you got to consider that your input in on that linkage is only going to go from like here to here. So like if it's a claw or something like that, you're going to have to kind of keep in mind just how far your stroke length is on that. But you can use that to do all kinds of linkages with if you wanted to. And that's basically my spiel on pneumatics. Lawrence has worked with them a bit too, so he might have some more Do you have anything you want to add to that? Is there anything you think I skipped there, Lawrence? Or
No, I think you got it all. It's yeah, I think you got it.
it looks really intimidating at first. Like when we first got the stuff, and thinking about what to do with all these hoses and everything, it's like, oh boy. But when you actually get into it, it's actually really simple. It wasn't nearly as bad as we thought it would be. Because we thought it was going to be like having to learn a whole nother thing all over again, but that really wasn't the case. So I'm sure there will be all kinds of uses for it this year. I'm sure. I know I saw at least one bot that actually kind of used they hung by it. Like they had like a little hook that shot out with their pneumatic, and they grabbed that low hanging bar, and then they just retracted their pneumatics to pull themselves up off the ground. And then I mean, there's all kinds. It's really useful. Like last year, for instance, when we were triggering our end game, we used it for that. And that was really useful. So any kind of thing where you have like something that maybe only needs to be triggered once, and that way you're not really wasting a motor on doing that. Pneumatics is kind of useful. But you do have to keep in mind that you only get so many activations. Of course, if you double the tanks, you can have more, but still, even with running 2 tanks, you're probably not going to get more than 20 activations out of it. And also you got to be aware of each time you're activating, the pressure is getting less and less. So it's not going to be holding as strong on that 20th activation as it would be the first. So you do have to keep in mind that you're only going to have a limited number of activations when you're designing around it. I think that's really all I have to say about pneumatics, except for I think it would be probably a good idea to see if we can find where we can order it. So I'm looking at the forum right now. Yeah, I think this is where I ordered from, actually. I'll share my screen one more time. So I was looking at this forum link right here, and I think this is the site that I ordered my stuff from. In fact, I guess it does remember me, maybe, or maybe it doesn't. So
you can get the whole kit from there?
Not the whole kit, but you can order the individual parts. So for instance, let me just let me go to another site. Give me 1 second. Let's go back to Advanced Robotics. And
That still says it's out, huh? That still says it's out.
yeah, yeah, all these kits are out of stock right now. Shoot, man, I didn't realize how expensive just a 2-pack of the cable. They're charging 33 bucks for that. But I think under kit contents, yeah, I think if you look up these part numbers, for instance, on this FCC website, if it would load, try refreshing that. me try putting in this part number here. So this is supposed to be the part for the Schrader valve. Did it find it? Nothing. Yeah, let's try another one. Let's just try the reservoir itself. Let's see if this part number works. Yeah. So yeah, so there were $33 each, or $32.06. And they have 11 of them in stock right now.
I think what it was when they add all the other charges, that's what made it 60. Like,
Yeah.
they got like, maybe you got to order a lot of things. You know what I mean? I don't know.
So let's see. So let's see if they have the cylinder. That's single action. Let's try the double action cylinders. Let's see how much they are. Yeah, so yeah, the cylinder itself isn't all that expensive. That's only about $18. However, it doesn't look like they have any in inventory right now. So it says, please allow 7 to 10 weeks for delivery. Now, I did actually, so if you're going to order them, you would probably want to order them relatively soon, I guess, so that you have time to get them by the time school comes in. But yeah, but I definitely did order extra pneumatic stuff through them this way. What would be some extra things I would want to have? Let me think.
For the kit, you need the valve, you need the T's, and the inserts, I guess, to connect it to the
You would need the solenoid.
solenoid.
Yeah. Is this the solenoid right here? This. I didn't find that. I remember somewhere on the forums, it had a link to a spreadsheet where they had all the Vex legal parts and where to find them. I'm just trying to okay. What I'm sorry, I kind of got lost in a rabbit hole there, reading over these articles. Oh, what were we talking about? Okay, just where to source the parts from. But geez, yeah. So yeah, $250 is a lot. It was a lot when we were ordering them because we ordered 5 kits. So but definitely so one nice thing about the pneumatics though too is like, for instance, you wouldn't necessarily well, you're going to need a solenoid for each each different thing that you're firing, but if you're firing, like, say, if you try to have several things fire off all at the same time, you can just use these T connections. Did I close my thing? Oh yeah, sorry about that. So like they have these T connections here. And so, like, for instance, on like last year's in game, we had like several pistons that were all hooked up to one solenoid through those T connections. So they just all fired off on that one single solenoid. So so if for whatever reason you have a mechanism that needs like multiple pistons to fire at the same time, you don't need to necessarily have to have a solenoid for each piston. You can use those T connections to run several pistons off the same solenoid, and that can be really useful. So it does kind of suck that they're still out of stock, though. I don't know. With this latest game, if you will necessarily have if it's going to be a competitive advantage to use pneumatics this year or not, because it at least, you know, with that your air reservoir is going to add a lot of weight to your robot. Well, not a whole lot of weight, but some. So it with the new motor rules and being able to use the smaller motors, it might be better to go that route if you have mechanism we need to do. On the other hand, one nice thing about pneumatics is, you know, once a match is over, the motors will go slack on you. So if you're trying to climb and you're using, like, say, if your brake types hold to hold yourself up, as soon as the match is over, you will slip back down again. But with pneumatics, they will be in whatever position they were in when the match ends. So so if you're using pneumatics to, say, like, clamp onto the pole, it should still hold even after the match is over. So that would be an advantage of pneumatics. Are you thinking about incorporating them this year, Sadie, if you can get them? Or
I would just like for all my students to know how to use them. I'm not going to tell them that they have to use it. I kind of leave all that up to them and what they think is best.
Yeah.
I just don't want them to not be able to use it because I don't know how to tell them to use it.
yeah, and it's just nice to be able to provide them options, right? So, but yeah, but if they do decide to use it, it's not really that complicated to use. So it may look pretty complicated at first, but it's really not that bad. My kids were able to pick it up pretty quickly. So
Yeah, it doesn't seem that bad.
If you can get your hands on them. Yep. Okay. So we have more time. I mean, we've only been on less than an hour so far. I feel like I'm just trying to run up a clock here, but it really, I mean, the whole purpose of me being there is just to kind of help you guys out with exploring things, because we don't really have a full set course. So I really want you guys to just tell me what you guys want, and we'll explore those topics. So I know we have, like, scheduled for next week, like the Onshape stuff. I know tomorrow, Sadie, you're not going to be around, right? And so I think Lawrence and I were just talking about meeting early tomorrow. And I think we were going to discuss, like, engineering notebook stuff. And what kind of stuff do you want to go over about the engineering notebook? Like, just
I guess just whatever you teach your students, and just, I guess, I know the other teacher, what she said, she made them write in that notebook every day.
Yeah. And that I do that with my intro to robotics kids too. I make them take daily entries as well. Just for their class engineering notebooks. As far as this year with our teams, I'm not I know at least 2 of my teams want to actually do digital notebooks this year. I think my third team still wants to do the paper notebook. So we're still kind of none of them have started a notebook for this season yet because we haven't really officially met any yet. But when it comes to the notebooks, what I usually advise my teams on is we kind of look at that judging rubric really closely, and so like for instance, we'll print out I'll print out copies of that judging notebook to give to all the kids, and they kind of keep that with them in their engineering notebook just to have there to refer to when they're making their entries. Though my teams are not perfect by any means as far as their notebooks go, but I think that it's really helped a lot just to make sure that they're covering what they need to on their rubrics. That video by 515R, I think that is their team number.
Yeah, you showed me that one.
Yeah.
Yeah, we looked at that.
That was a pretty good one. There's I think there was like a one from a long time ago that would show pretty often. It was a little more tongue in cheek. But it was from a couple of years ago. Oh, yeah, there's a ton of teams that put out videos for their notebook or talking about how to do a notebook. I mean, I guess not. I'm sure some of these videos are better than others, but another thing I would probably suggest looking at would be the what's something that I had my kids look at last year? It like from the REC conference. They're yeah, so
the first day that we signed up for Monday.com, our department was already able to connect our.
So like these I'll share my screen one more time. Like these videos from the from their summits, their like event partner summits. Like this was one on how to judge design notebooks, and I do actually have my kids actually watch these because this is what they're presenting to have judges to show judges what they should be looking for to judge a notebook. And so and that's what the kids really kind of need to know, right? As far as that goes. So let's see. Like for instance, it talks about so Yeah, so and they have these summits every year, and so they're kind of always changing. They haven't had their summit this year yet. I think it's in where is their summit this year? I think it's in, I don't remember. I'm kind of blanking now. I guess it doesn't really matter since we'll probably just end up watching it virtually anyways. But I feel like that's a good resource for the kids too. It is, it is a bit dry because it's adults talking about some really technical stuff. So some of your younger kids might, really glaze over on that. But for those that are really concerned about having a good notebook, I think that would be helpful. Just looking at those things. There's also always doing or having your kids actually do the judge training, like and getting their judge certification, just so that they understand the judging process. That's another thing you could do for kids, especially for the class. That could be one of the things that you have your students do in the class is go through the judge certification. That's REC Foundation Judge Certification. Or even just having them read that judge guide, which is pretty long, but let's see, how big is that judge guide? It's pretty big. It's
Can you present that?
The judge guide?
Yeah, on your screen.
Yeah. Here's the link to they haven't updated it yet. But here's the link to the judge guide right here. I put the link in the chat. But it goes over the rules for judging. Kind of timelines, what the qualifying criteria are for the judging, the process for judging, what you should consider for the different awards. And so, like, for instance, this section 5, it goes into detail about how to judge a engineering notebook. So that would be an important section to have your kids read over, because this is what the judges are using. So the kids really should be on the same page as that. And then it even goes over like sample questions and how to sort out and decide who to do it. And it also gets into some of the different forms they use and the rubrics. And I just find it really helpful if the kids have this and are able to read through this information themselves. Not all of them are going to do that, obviously, but you'll usually have at least one person on their team that does care enough. And hopefully it's the person that's in charge of their notebook care enough about this. Usually that's not always the same person. So, but that's kind of how that's probably what I would do with the kids, is have them kind of read through the judges guides, maybe do the judge training. Because that way they will know what goes into getting the awards, basically. I apologize. I just don't feel like I'm on top of my game right now. That's why I'm kind of like struggling to keep the conversation going, I guess you could say. But those would be kind of the resources that I usually do with my kids. What do you guys usually do to help them prepare for their like with their engineering notebook? Is there any particular things you guys use, or?
Hey, sorry. Yeah, so I make my kids look at the judges thing as well. Sorry, my phone had fallen. But what was a hold on. Okay. I've also, this isn't really for the engineering notebook, but like I've brought in outside people to interview my kids.
Yeah, that's a good
and just
idea.
kind of give them sample questions. And then I make them like document that in their engineering notebook and just kind of make sure that they have an entry for every day that they work on their robot, who worked on it, you know, who is in charge of what. I tell them to include pictures everywhere, drawings, you know, actual pictures, any calculations that they have, I don't know, things like that.
Mm-hmm. Yeah, that's that's a really good idea, having mock interviews, especially with outside people, because it is kind of true that you can kind of get biased if you're interviewing them, so it's good to get an outside perspective on that, for sure.
Yeah, and I give the judges the actual, you know, interview rubric, and kind of, you know, give them like a little explanation beforehand and what to look for, you know.
Mm-hmm.
And then we did it a few times throughout the year. Like I didn't just do it once, and I did it with different people every time.
So did you like grab like fellow teachers, or was it like people like in the industry, or?
So the first time it was fellow teachers, and then the second time it was our principal, our chief academic officer, and there was a third person in there. I can't remember exactly who it was. But our chief academic officer, I don't think he ever worked in the industry, but he has some sort of like engineering degree. I don't remember exactly what it was. But one of my plans for next year is to reach out to our partners in education and try and get volunteers from them to come and interview the students, like do a mock interview.
Yeah, yeah, I think that's a great idea, for sure. We do mock interviews occasionally. I usually I always usually use like a fellow teachers, just because they happen to be around. Um, I haven't really tried to go out of my way to grab like say, one thing I should probably do is try to maybe reach out to some of our sponsors to see if they would like to be more involved that way. 'Cause
Oh,
I'm
that's a
sure,
really good idea. I think they really like doing that. Yeah.
yeah. Um, do you have any input, Lawrence, about?
I
I
mean,
mean,
I guess the kids, they go online and they try to find as many videos as they can, and you know, about the notebook, and uh Yeah, I mean, I've got this couple kids. They're not even in the robot class, you know, and they're the ones that went and bought a field and put it in their living room, you know, and
That takes some dedication for sure,
right. I mean, they just
especially for the parents to have that up in their living room. uh did they just leave it up all year, or
yeah, pretty much. They just built it and left it up there all year. It's still there, you know.
I remember when we were doing did you do any of the live remote stuff like during change up?
Yeah, we did.
Yeah.
We did the world well, we did the one that was at World with the it was the one with the balls.
Yeah, the tic-tac-toe kind of thing.
Yeah.
I just remember from that, like a lot of times seeing like people's living rooms and stuff. Like there were like a lot of kids that were doing it in their garages and in their living rooms. So I do kind of remember that. I was thinking, that's something else to have all that up there.
Yeah, yeah.
Okay. Do you guys want to call it a day?
That's
I'm
fine
good
with me.
that.
I'm still not home yet, so
Yeah. I'm just not sure how much more. I'm just blanking on ideas to talk about right now. is kind of what is where I am at right now. But if there's any other topics we want to address right now, I'm certainly open to it.
I mean, I'm good with starting back up tomorrow.
I'm sorry, Lawrence. I think I missed what you were trying to say.
I said I'm okay with finishing today and starting back up tomorrow.
Okay. Well, how about we do that then? So I guess tomorrow, Lawrence, I guess we'll just get on at 1:30. Does that sound good?
Yeah, that sounds good.
Okay. All right. Well, in that case, Sadie, if we don't see you again before then, have a good weekend, and we'll see you again Monday.
okay. And that the recording will be posted for
It should.
tomorrow.
Yes.
Okay.
Vanessa has been keeping up the postings, right? Let me look on the Google Classroom.
Yeah, I haven't really been paying attention if she has or not. So
Yeah, I honestly haven't too much either. Let me pull up Google Classroom. I have to go to my other account. Advanced Robotics. Yeah, she's been posting them each day.
okay, awesome. Well then, yeah. I will see y'all Monday.
Okay, have fun at your wedding.
I will. Thank you.
All right, Lawrence. I guess I'll see you tomorrow at around 1:30 then.
Okay, sounds good.
Okay. Have a good afternoon.
All right, you too.
All right. Bye.
Bye.